So it's LeetCode problem 1749, maximum absurd sum of subarray. So in this problem we are given an array of integer nums, and we need to find a subarray, so a continuous part of the array such that the absurd sum of this subarray is maximum. So see, so absurd sum is equal to sum of subarray. Okay, so we have to return the maximum absurd sum. So if we have nums like these 1, -3, 2, 3 and -4, okay, first make a subarray of this is 2, 2 and 3, and next is 4, -4. Okay, so the sum of this is -2. We convert this is 2. Okay, the sum of this is 5, so the answer is 5. Maximum is 5, so it's -4. If we convert areas, it's look like 4. So the maximum is negative, so the maximum is 5. So if we have nums like this 2, -5, 1, -4, 3 and -2, so let's make subarray of this is 2, 2 and -5, 5, 1, -4 and 3, -2. So sum of this is 2, so sum of this is -3, so sum of this is -8, so sum of this is 1. So is ABS is 2. If we convert this in ABS, it's become, this sign will go, so answer will become 3. So ABS of -8 become 8. Okay, so -1 becomes 1. No, it's 1 only. So we use ABS to remove the signs. Okay, so the maximum is this -8. So we want maximum absurd sum, which means maximum positive sum, largest sum of any subarray, and maximum negative sum, smallest sum of any subarray. So for maximum we are going to use max sum, and for minimum sum of subarray we are going to use min sum. Okay, so let's try that. First we make this 4 variables. Current max is 0 because current positive sum first, and max sum is 0, maximum positive sum, and next is current min is 0, current negative sum, and min sum is 0, minimum sum most negative. Okay, so we traverse the array. So let's try that. Okay, if we have nums like this 1, -3, 2, 3 and -4, so the current max is 0, max sum is 0, current min is 0, so min sum is 0. Okay, so the first one is 1. See, current max is 1, 0 plus 1 is 1, and max of this is 0, 1 is, so max is 1. Okay, in minimum current min is 1, 0 plus 1, so 1. In the minimum is, so the minimum value is 0. Okay, next one has over, next we comes here, so our I is here and becomes now here. If we I, okay, so in max, so -3, 1 minus 3 is equal to 2, so max is 1, -3 is 1. Next is in minimum, so that this is maximum. In minimum, yes, -3, 1, -3 is -3, so 0, -3, so the minimum is -3. If I becomes 2, I comes here 2, 3, -4. Okay, I comes here, So current max is 2 comma negative 2 plus 2 is 2. So the max is 1 comma 2 is 2. In minimum 3 plus 2 is negative 1. So minimum is 3 comma negative 1. So the answer is negative 3. So our I comes here. It comes here. So the value is 3. Yes. So current max is 3 comma 2 plus 3. So it's 5. So the max of 2 comma 5 is maximum is 5. In minimum 3 comma negative 1 plus 3. So 2. So minimum of this is negative 2. This is 2. So minimum is negative 3. So this is 2. It was 2. Okay, so the answer is negative 3. So our I comes here in negative 4. So I comes here. So max of this is negative 4 comma minus 4 is 1. So max of this is 5 comma 1. Maximum is 5. In minimum negative 4 comma 2 minus 4 is negative 4. 3 comma negative 4, answer is negative 4. So the final answer we calculate max of 5 comma 4. So the maximum is 5. Okay, so the maximum is 5. So let's write down the code. Current max is 0 and max sum is equal to 0 and current min is equal to 0 and min sum is equal to 0 for I is to nums. So current max is max I comma current max plus I. Next max sum is equal to max sum comma current max. Now current min is equal to min I comma current min plus I. Min sum is equal to min sum current min. Now we just return max sum yes min sum. So in this we tag both the maximum and minimum subarray sum using Kadane algorithm, then return the largest abstract value. So the time complexity of this is big of n because we traverse the array once, and space complexity is big of 1 because only few variables are used. That's all.